Hi, good evening to all the students. Yeah. Okay, you can hear my voice clearly or not?
Yes.
Yeah, okay. Thank you. Yeah. Okay. We will continue with our following section. Okay. So I have shown it to you the two factorial example. Okay, factorial design example. So after that you can imagine that you have an iteration effect there. Okay. Then in this example, the iteration effect is a significant. So when we want to interpret the results, we need to take care. We need to interpret it one by one because of the iteration effect is a significant. Okay. We cannot be interpret the temperature and the type of the material separately or independently. We need to take care about the iteration, the type of the material at a certain type of material for the different the vary for the different temperature, or you fix it at a certain level of the temperature, you vary the type of the material. So this one is where the iteration will come in. Okay. Then for your information, what we have studied right now is just an iteration, the only for the two-factor case. So you can imagine it if you have a many factor to be considered. For example, you have a three factors. How many iteration factor will be involved in your model? So when you have a more than 3, 4, 5, and so on, so your iteration effect will be affected your results. So in that case, the iteration will be very hard for you to make the interpretation, especially you deal with the higher level of the factorial design. You have many factors. Okay. So this is an example for your just two factors with the only one iteration effect. Okay. And then I also it always will emphasize on you how to get the formula for the fitted equation and the residue. Because this thing, when we testing you the exam question or the test question, we need you to understand about the background of your study, not just apply the formula or just use the software, then click, then you get the answer. But even though in the whole ANOVA table, I not mentioned to you that if like just now, this is the ANOVA table. If I not mention that which one is a MSE, you also not aware that this thing, the MSE is actually the estimate of the variance. Okay, so this one is how important you need to know the background about it. Then how do you want to make sure that this thing is correct or wrong? If somebody give you this type of the table, they will ask you, in this analysis, how many levels you test for the temperature, the type. Then from here, degree of freedom, what is the meaning? That is A minus 1. So therefore, you know that you are testing the temperature at the 3 levels. Even though the material type, also you test at the 3 levels. If you're able to understand about the whole table here. So therefore, the background of the study is very important. Degree of freedom is the A minus 1. That is a B minus 1, and so on. Okay, so from there, we will know that how we want to extract the information. Okay, so this one is I stop until the residue here part. Okay, so the following one I will go through with you is this is an example, because if you have a Minitab software, then it's a very fast. They can produce you directly the ANOVA table is very nice form. Okay, of course, if you're using the R, if the software is not, nobody is writing the codes for that particular analysis of variant, then you need to do the programming your own. But when you deal with the programming, of course, you need to deal with do the computation. So you need to apply the formula inside, then you only can write out the program. Okay. So here, because before that, I gave the student is a Minitab, because during it's not the you still can come to the uni, you still can use the software. Therefore, I will show it to them the Minitab. Okay, so this one is the result from the Minitab, where they use the different name, even though there is ANOVA table, but in the Minitab they use a name as an error, what we are using just now. Okay, but in the R they're using the different name as a residue, so you won't be confused that if they're talking about error, is it this error is a residue or the error? You need to be clear, okay? Because different software, they're using the different name. Okay. So this one is a plots from the Minitab. They will produce for you all the residual plots of the analysis, whether they fulfill the conditions of the three assumptions. Okay. So here is, I think it's a repeated. Okay. So this one is a iteration plot where just now I have shown it to you. You can see that using the material type number 3, you will get your higher mean life. You using the low temperature, you will get the higher mean life. Okay. But you cannot say that based on the individual plot itself, I will decide to select the level number 3, and then I will select the level number the 15 temperature degree and the third material type. Then this, based on these two, they will give me the highest. But if you observe the iteration carefully, under the 15 and the level type number 3 is a green color, you don't get the highest mean. You only get the second highest. So therefore, if you have an iteration effect there, you cannot be just look at the outcome for each mean effect separately. Okay. So this one is what you explain to you why the iteration will play the important role out here. Okay. Okay. So the second one I will go through with you is if let's say you do not have the number of replicate, have the maybe I will go through the first one is if you do not have the iteration first. Okay, so if your model do not have the iteration, then you can reduce your model to the only study their single factor, the factor A and the factor B alone, without any iteration. So the analysis is possible to run it. Okay, where you no need to involve it. How do you know that whether you need the iteration or not the iteration? Of course, you can run the full model. Full model is just now the previous example. I will run the full model first. Means that I consist of the factor A, factor B, and the iteration. Then I do the testing. If the iteration is not significant, then I can reduce my model to the only two factor here. Okay, only consists of the factor A and factor B without the iteration. Then I test the model, whether the model is a significant, the significant in the factor A and factor B or not. Okay, so your model is possible, consists of no iteration. Okay. Of course, you can be compared also. Another thing is you can compare the model. This one is without the iteration. The previous model with the iteration. Okay, if you refer to the Minitab result here, the result here also they include all these things. Under the regression analysis, they have a R square. With the iteration, you have a R square here. You have a without the iteration, you also can have a with the R square. So you also can be select the model, which model you want to use with the largest R square. This one is another criteria if you want to gather the information. Okay. So we go back to here. Is where you only have the where you only have the iteration effect here. You know iteration effect here. So the model will look like this thing. Okay. So we refer to the example 5.1 here. Just now the previous example. What if I do not involve the iteration? So when I do the analysis of variance, I only need to write it just the temperature plus the type. I do not put the multiply. If I directly put the multiply, then they will involve the iteration effect. If I do not do the multiply, I just put the temperature plus the type, then they will only give me these two things. Okay. So if you observe this thing, the temperature and the here, you can observe that the temperature, the sum of square is still remain the same. The type will be still the same. Okay. So I can be summarized in this way. If with iteration, you have a sum of square for total will equal the sum of square for the A plus the sum of square for the B plus the sum of square for the AB plus the sum of square for the E. So without iteration, then you have a sum of square for total. Okay, you will group back these two together to here. Okay, you will group them. You don't partition it out the iteration effect there. Okay, so without the iteration, in fact, the sum of square will consist of these two. So therefore, if you compare the example 5.1 and the example now, the temperature, your sum of square for A is still the same. The sum of square for the type, okay, the type material type you will get is 10684, also remain the same. The only thing is the sum of square for the overall. Here, this one you already combine back to the sum of square, where it consists of the AB and the E. Okay, so your degree of freedom for the residue, because you do not have the iteration term, so the degree of freedom for residue is 31 here. Okay, because total out is 35. Okay, total degree of freedom is n minus 1, therefore you get 35. Okay, so from this test here, you also can see that there also is a significant difference. Okay, sometimes if we of course this one is they will have a significant difference, but sometimes you can get the opposite result if with the iteration without the iteration, because the MSE here is become larger. As you can see, you combine these two together, become the new SSE, the value become larger. Okay, so this value is become larger when you want to get the F statistic here. Okay, you can get the F statistic here. The F will equal to the MSA divided by MSE. Okay, so if you get the larger value of the MSE here, so means that the whole ratio the ratio of these two number here is become, so the F value will become small. Then you have an intention to get the answer is do not reject the H naught. But because this one is they are highly different, therefore the F value is very large. Okay, if you observe F value you get is a 20 for the temperature is a 28 in the previous state answer, but now I combine it without the iteration, the F value will become drop. Okay, so this one is the case for the no iteration. Iteration, under the case of the no iteration, of course your model have changed. Since your model have changed, then our estimation also will change, where you have the estimate of the here, you only have this thing, the estimate for mean is of course is still the same here, but your tau I will equal to the I dot dot minus by the overall mean, and then your beta will equal to the, okay, so you only have, because without any iteration anymore, so you only have these three components. Therefore, repeated equation right now will equal to the mu hat plus the tau I plus the beta j hat. Okay, so this one you just substitute it inside. So you get your the fitted equation will be different from the just now the fitted equation, because the model you have changed the model. Then after that, of course, the residue will equal to Eijk, will equal to the Yijk minus the fitted value of the Ijk. Okay, I do not ask you to calculate all the residue or manually. Okay, you can be, once you get your fitted equation, of course you can be put in the Excel. If you do not want to use the programming parts, then you can be put in the equation, put in the Excel, and then do the calculation residue. Then after that, only go to plot it. Normally, I don't ask you also during the exam, ask you to do the residue plot. No, I don't ask you this type of the question, because I think that one is you for the assignments or for the practice, you can be do it your own. Okay. Another special case is for the case of the one observation per cell. If you still recall back, just now I have mentioned to you, if we want to run the factorial analysis, we must make sure that our n is more than or equal to 2. So the sample size must be more than 1. If your n is equal to 1, then you will get your 0 for the SSE. Okay, but we have a case here where we also can have an alternative using the single replicate. But if you want to use a single replicate, then of course you need to give out certain information. So what are the information you need to give out? The information you need to give out is if the n is equal to, this one is for the case is n equal to 1, you cannot have an error, the sum of square for error. So if you're willing to give out the information of the iteration, then this iteration sum of square will become your estimate of your sum of square for error. Okay, so this one is occasionally one encounter a two-factor analysis only single replicate. So means that is only one cell, one observation per cell. So our model is still remain the same. Therefore, you can't see the k because the k is equal to 1 here. Your model is still the same except the third subscript is a 1. So therefore, I don't need to write it out. So the analysis variant in these following tables, we cannot estimate the error. I mean the error is not this error, the sum or square for the error. So we see that the error variance sigma square is not estimatable. So that is two-factor iteration and the experiment error cannot be separated in obvious manner. So therefore, you cannot have any test to testing for your main effect because our study here is we want to study the factor of the factor A and the factor B. So how are we going to do that? We need to give out certain information we want to give out. We need to give out the information of the iteration. If the iteration is not significant, therefore this component can become our sum of square. So I can write in this way. You can have a SS for the total is equal to SS for the A. Okay, the sum of square will be given by this thing. If let's say for the case is n is equal to 1, your SSE will equal to 0. So if your SSE equal to 0, your model is only SSDOT will equal to SSA plus the SSB plus the SSAB. Okay, if the AB is not significant, the sum of square for not significant, then this one will be throw it to the SS for the error. So this component we can use it for the SS as an error. Okay, because this part is 0, these two combined together, they can become the error. Then in that case, we want to testing for the factor A and factor B, then we can do that. Okay, where your residue is come from the sum of square for the AB. Okay, yeah. So this one is what they mentioned to you that in this case. Okay. So therefore, you get the mean square for the A. You get the mean square for the no need to plus. Okay, yeah, not the plus. You get a mean square. You get the mean square for the B. Then you get the mean square for the AB. So if you want to test for the factor A, so the F statistic will be equal to MS for the A divided by MS for the AB. Similarly, for the factor B, you have a MS for the B divided by MS for the AB. Okay, means that you need to make sure that this iteration is not significant. If the iteration is still significant, of course, you can't do anything. Okay, so of course, you cannot test the iteration significant or not significant because if your n equal 1, your SSE already 0. So the SSAB, you cannot test anymore. You need to give out this information. If you still want to continue testing for the A and B, then you need to think that this one is become your MSAB. So therefore, your test statistic should be MSA divided by MSAB. MSB divided by MSAB. Okay, so this one is all about the under the factorial analysis, where the first one is n is equal to 1. You only use for the single observation. The second, you you do not involve the iteration effect. Okay, so most of the time when we go to the higher level, our iteration effect, we will try to ignore it. Especially you have a 2 iteration, 3 iteration, 4 iteration. Let's say you consider of the 4 factors, factor A until the factor A, B, C, D. You consider 4 factors. Then you, of course, you will have the 4 iteration together. So most of the time, the higher order of the iteration, they are not significant. So that one you can be, the remove away, or you can be group it, then they become the SS, SS for the error. Okay. So until this one, then should be, I will stop until this part here. Okay. Maybe I will show you just one more slide. This one is what they say that. Now, this one is I say that the MS residue or the AB will be together. So therefore, when you divide it up, you have a MSA divided by MS residue, and SB divided by MS residue. Okay, but this MS residue is actually is come from the AB. Okay, yeah. So until this part, then to be the last slide for my here. Okay, the last slide for my section here. Okay, so after this one, I will go through. I save it first. Okay, after this one, I will go through the tutorial. Okay, after this page, I will go through the tutorial. Then after that, we will continue for the the following section for the general factorial in the next week. Then together with we have I have uploaded the latest notes also for the 2 power of k factorial design. Okay. So for the 2 power of k factorial design is also the idea is similar to the factorial design you have. Only there is a special case for the factorial design. Okay. So they only consist of the 2 level. Okay. So I will stop until here. I will stop until here. Then I will continue this thing. Okay, I will explain this thing in the next week. Okay. But anyway, for this lecture notes, I will upload these lecture notes to the, the answer just now I written one, I upload to the, sorry, let me stop first.